There are 3 green, 2 red, and 4 marbles in a bag. You're drawing 2 of them in a row. Determine the probability of the following. Answer with and without replacement. With and without replacement. So what we're going to do here is we're going to have 2 columns here. We're going to have one that says replaced, replacing, and another column right here where it says not replaced. We're going to compare our results side by side. And just so you know, if it reads like this, it's picking green, that's your first event, and then picking a red one, that's the second. I have to emphasize this, that we're saying that the first one is a green and the second one is a red, like order matters, okay? And I would like you to use the fundamental counting principle with these types. So probability of green and red, can you practice the notation like this? In this case, if you're replacing, these are independent events. And this is how I'm going to show you that these are independent events. I'm showing my audience, which is you right now. I'm just going to take the probability of green and multiply it by the probability of getting a red. What is the probability of getting a green? It would be 3 out of, did anybody do the total already? 3 and 2 is 5, and 4 is 9. 9 total. Okay. So this would be 3 out of 9 multiplied by, we're putting this one back, guys. We're putting this green one back into the bag, which means we still have all 9 remaining. How many are red? 2. So this would simply be 2 times 3, which is 6 over 81. You're done. Okay? This is it. This would be the answer in this case. However, listen to this part, guys. I know you're already thinking of the long weekend. I don't blame you one bit. When you're not replacing, we're talking dependent events, right? Where the first event will affect the second one. This is how I will show you that that's happening here. So we will take the first marble, which is green, and we will multiply it by, ready for your new notation that you're going to learn today, probability of a red, hint, hint, given that I took out a green one. When you're writing this down, you're letting your audience know, oh, you're not putting it back, you're affecting it. Okay, got it. I can't, will it be 9 and 9 in this case? Will it be 9 and 9? It will not be. It will be 9 and 8. So, for the first one, how many greens do I have at the very beginning? 3 over 9, no big deal, right? For the second one, I'm going to use a red pen for this part. We're down to 8. Listen carefully. Did the green one that I picked on the first one, did it affect the number of red ones that I have on the second draw? No, I still have all 2. So that's good. The total has definitely been affected, but the number of reds has not been affected by the first event. How would the number of reds been affected by the first event? What would have had to have happened? I would have had to have grabbed a red one, right? For it to affect the number of reds for the second go. So no big deal there. 2 times 3 is 6. 9 times 8, 72. Notice how your answers are different, right? Because the fact that you haven't replaced. Let's try another one. 2 blue marbles. Replacing. Can you practice this? Probability of blue and blue. It'll be probability of blue times probability of blue. Mr. Dirksen, do I need to have this notation if I do my test? No, you don't. I won't care. I just need you to be comfortable with notation. How many blues do I have? 4 out of 9. And I still have all 4, and I still have all 9 because I'm replacing in this first column, right? Am I giving you guys a headache? I do. I know I'm doing that. I'm going to try to remedy that next week, but you have to practice. So this is my answer here. Let's do 2 marbles here. Probability of blue. What will I say here? So probability of blue and a probability of blue again, right? Given that a blue one has been removed. Hint, hint, right? It's almost like your probability of doing your job and getting video games, like my kids at home. Got to do your job and then you get video games, like, oh, well, it's a probability of me doing my job and probability of playing video games, given that you've done your job, right? So same idea, like it's dependent. So probability of blue is 4 over 9, just like before. However, what's going to happen now? I hope you all understand that we're down to 8, because we're removing, we're not replacing. What about the top? Do I have all 4 blues left? Nope, it's 3 now. So now your probability is 4 times 3 is 12. 9 times 8 is 72. So that's how your answers are different. Okay. I will let you do C and D. Before we go, I want you to try. I want to skip to E, because that's a classic as well, by the way. I would almost say have this on your study sheet. Have one of these examples, and then this one down here. What does 2 like-colored marbles, what does that mean? I want 2 the same, right? The same color. That means that I can have 2 greens, or 2 reds, or 2 blues, right? Do you agree that this is cases? Cases. Because it's, hey, if you say 2 like-colored marbles, I mean, there's options here, right? So green and green would be what? 3 over 9 times 3 over 9 plus red ones, I've got 2 over 9 times 2 over 9, because I'm always replacing everything. And then blue ones, I've got 4 over 9 times 4 over 9. This would be 9 over 81 plus 4 over 81 plus 16 over 81. The nice thing is you're always going to have the same denominator, so it's easy to add it up. Nine and 4 is 13 plus 16 is 29. That's your probability of like-colored marbles. It's a smaller probability, right? It goes down. How are we doing? What does this column represent? We're not replacing? Okay, let's do this. So 2 green, or 2 red, or 2 blue, again. How about we do a little bit of, we know that it's going to be something times 9, and then something times 8, correct? Plus something times 9, and then something over 8. Plus something over 9, something over 8. Every time the total is going to go down in every single case. My green ones, I have 3, and then I drop to 2. The red ones, I've got 2, and then I drop to 1. The blue ones, I've got 4 to begin with, then I drop down to 3. This will be 6 over 72 plus 2 over 72 plus 4 times 3 is 12, right? 9 times 8 is 72. So that's 20 over 72. Which one of those two is more likely to happen? With replacement or without replacement? What's 29 over 81? That is 0.36, right? And this one? 0.28. So it's more likely to happen if you replace your marbles after every draw, right? Then it's more likely to happen. Okay? Okay. I want to try just page 40. However, because it's a long weekend, is there a blank page that I can insert this? Yeah, page 7. Okay, page 40 plus handout online, though. I haven't printed it. I just finished writing it based on this lesson because I felt like I wanted a little bit more. Can you do this on page 68? On page 68, you have a blank page. You answer the questions on like that. I'm going to post that handout, okay? It seems like a lot, but to be honest, you could probably finish it in 15 minutes. Please do that handout online. It's going to ask you to practice dependent versus independent events. I have some cards. I have marbles. I have chocolates. So if you eat a chocolate, if I take a chocolate out of the bag from my kids, because they don't know, right? And I eat it, and I take another one, independent or dependent? If I eat it. Is the first one affecting the second outcome if I eat it? I don't put it back, right? So if I eat the chocolate, now it's dependent events, right? So we've got 2 dependent events. So I'm going to ask you to try that. Answer on page 68, please. The key is attached to the handout. So if you look at the bottom of that handout, the key is there, okay?